decimal. Now, if a fraction, we decided to resolve a fraction. Remember, a fraction is having an integer up and an integer down. If we decide to divide this fraction, probably using long division method, you will realize you'll be having integers that are not exactly integers. Yeah, what do I mean? Integers that are in between integers. We know integers, for instance, let's say we have 1, 2, 3, 4, they are whole numbers. Let's resolve this using long division. Probably using long division, you should be having 0.66666666666, and so on and so forth. You should be having 0.66666. Now, 0.6 is not an integer. 0.6 is a number lying in between 0 to 1. So when we have numbers in this form, they are regarded as decimal. They are regarded as decimal. So when we have numbers that are not exactly integers, that is whole numbers, that number is regarded as decimal. Decimal numbers carry out the same operations as fractions and even integers. Yes, operations like addition, subtraction, division, and multiplication, even following the rule of BODMAS. But we need to know a little twitch in it. They come out subsequently in our year-to-year exam questions. So let's say we are asked to add 3.2. So addition of decimals. Addition of decimals. We are asked to add 3.2 plus 13.5. 3.2 plus 13.5. So if you have to add this, we'll make sure we arrange them in their place order. Yes, 3.2 we having. One rule of thumb I give students is to make sure the decimal points are all arranged at on the same line. You can see, I make sure the decimal point is here. Imagine I add 0.005 plus 0.005. So if I'm to add this plus 0.005 to this addition, I'll make sure that the decimal points are all aligned at the same location. So we'll be having 0 here, 0.005. So that's an easy logic. That's an easy logic for this. So we have this as the unit, tens, hundred. You see, all units are all aligned at the unit section, and we have the tenth, hundredth, thousandth. Why this one is tens, hundred, and thousand. So they must be arranged on their place order. So we can carry out this operation seamlessly the same way we carry out integers. Here we don't have any number here to add up to this 5. The numbers are insignificant and they are 0, and 0 to 5 gives us 5. 0 plus 0 plus 0 gives us 0. 2 plus 5 plus 0 gives us what? 7. The decimal point comes out, and we're having 3 plus 3 to give us 6, and here we're having 1. So this is 16.705. In the same manner, we could also do subtraction operation too. Make sure they are all arranged with the place order. Let's say we are asked to subtract 13.5, subtract 0.12 from 13.5. Remember, the same way, make sure it's arranged in the same place order. Let's say 13.5 to subtract decimal point here, 0 here, 1 here, 2 here. Easy. So let's subtract this. For this subtraction operation to occur, we must subtract something from these two. There is an insignificant 0 here. So when we borrow 1, actually it's not 1, we are actually borrowing 10 to this place. It makes this what? 10. Because I will explain that in our number base class. 10 minus 2 is what? 8. Here we are left with 4. 4 minus 1 here is what? 3. 3 minus 0 gives us what? 3, and we are left with what? 1. So this is what? 13.38. What we just did now is subtraction operation of decimal. Subtraction operation of decimal. Now let's go to multiplication and division. Multiplication and division of decimal. 0.056 times, let's say 0.12 for us to multiply. The multiplication operation of decimal is easier too. It's just that students don't have a little clue on how to solve this question, and I'll give you that expo now. When you want to solve this kind of question, remove the decimal point, because that's the thing causing confusion. But when you are removing the decimal point, make sure you know the direction at which you remove the decimal point and how many times you remove the decimal, how many times it takes you to remove the decimal point. This is the decimal point here. Now let's remove this decimal point. I'm removing the decimal point 1, 2, 3 to the back, because every whole number or every integer has its decimal point. Let's say I call a number 15. 15 always have a decimal point at the end of it. So I've just taken the decimal point to the back, and we'll be left with what? 56 here. And this decimal point for this, I take it backward also 1, 2. Remember how many times I've just moved this one? 1, 2, 3 times. I'm moving this one to 1, 2. So I move this one 2 times. So I have what? 56 and what? 12. We do the operation the normal way we know it. So that now with the decimal point backward 3 times here and take it backward here 2 times. So we'll do the reverse to return it back to its normal standard form, normal decimal place. So we took it backward 3 times. So let's take it forward back 3 times. 1, 2, 3. So this is where the decimal point is currently. So we also take the decimal point backward twice here. We'll take it forward twice. 1, 2. So this place filled with without any number, we put 0 there. So the decimal point is currently here. So our answer is what? 0 point, because this is the point. Note, in front of no value here is insignificant, and the 0 is what is there. So we have 0.00672. So the multiplication of 0.56 will give us what? 0.0672. A very simple operation. Let's do for division. If we take the division to this side, we can have 56 divided by 12, then we get our answer and move it back again, the same way we did it. Sometimes your question can be given in this manner: 0.056 divided by 0.12. Most times this is the way you see your questions. It makes it more easier is to move the decimal point. Whatever direction we take the decimal point, also eliminates direction we take the decimal point in the denominator, eliminates the direction in the numerator. What do I mean? If I take the decimal point here, 1, 2, backward, making this 12, which is our target, it will make this numerator the same thing, 1, 2, as what? 5.6. Are you getting that? And it's easy to operate this way. If you want to also remove the decimal point totally, you'll be having, when you move the decimal point in the numerator once, the same thing you do to the denominator, you add 0 here. Why? Because there's a decimal point here that will also move once. So we have to add 0 here, and we'll be having 120. Now, if we do long division of this operation, we'll be having what? 0.466666, and so on and so forth. So we'll be having large decimal place numbers that we cannot manage. In our next video, we'll be talking about significant figure and decimal place on how to approximate them. But before we go, let's quickly treat a JAMB related question on multiplication and division of decimal numbers. Now let's quickly do this. Remember, when we have 3, 5, 2, 4, this is the main operation and we are working on. Now to solve this, the main thing is make sure our denominator does not have decimal points. That is our target. To make sure our denominator does not have decimal points. It will be easy to solve. So when we take this backward, the decimal points backward, 1, 2. It will also affect the up here. Remember the decimal point is here for every integer. So it will move twice to 1, 2. So when it moves twice, we'll be having 0 here. So this can be rewritten as 3, 5, 2, 4, 0, 0 divided by 1, 2. So we are left with 5 because this 0 in front become insignificant. So this is 5. Let's divide it fast as possible. So we're having 5 here, 1. 5 in 35 will give us 7. But it's healthy you don't do that. Because of anytime you divide, it's always good you have a remainder to continue the division process. So what you do is divide 5 in 3, 5, 2. 5 in 3, 5, 2 is now what? 70 remainder 2. So let's write that out. 70. Okay, right here. 70 remainder 2. This remainder 2 comes here now. Remember, I didn't go 35. Now 5 in 24. 5 in 24 is 4. 4 remainder 4, because 5 times 4 is 20, and the remainder 4 comes here. 5 in 400, 5 in 400 will give us 80. So we'll be having what? 70480. So a quick explanation to significant figure, even though this video is not meant for that. They said to treat significant figure. Significant figure, we start counting from our left, a non-zero digit from our left. So this is non-zero, so our significant figure start from here. 1, 2, 3. So 3 significant figure, this is the one we are considering. The next number after it, we are going to round up because the number is from 5 to 9. Look at that, is 8. We are going to do what? Round up, and when we round up to this, it's giving us 70500. So the correct answer is 70500. Now take this one and solve and drop your answer in the comment section. If you're asked to evaluate 29 divided by 3, 21 divided by 9, let's do that, and correct to 3 significant figure. Thank you.